Chapter 4.2, apply congruence and triangles. So in this section here, we are dealing with congruent figures. So for congruent figures, that just means they have the same size and shape. Okay, they might be oriented different ways, but as long as they have the same size and shape, they are congruent. And of course, not congruent means they have different sizes or shapes. Now let's say we have a statement like so. All right, I'll highlight this right here. Triangle ABC is congruent to triangle FED. Now you can tell which angles are congruent just based on this statement. All right, we can match up the first letters, the second letters, and the third letters in this statement to see which angles are congruent or the same. Okay, so this triangle symbol, of course, that means this is a triangle. All right, if you look at the first letter, that's an A, and the first letter over here, that's an F. So that means angle A is going to match or be congruent to angle F. Then if you look at the second letter, we have a B and we have an E. That means angle B is going to be congruent to angle E. And finally, if you look at the third letters, we have a C and we have a D. That means angle C is going to be congruent to angle D. All right, so that's how you can tell which angles are congruent. Now, we can do the same thing with sides. Okay, we know the sides of a triangle or any polygon are actually line segments, so we have to do two letters at a time. All right, so let's start with the first and second letters. All right, first two letters, AB, are going to match first two letters, FE. So AB is congruent to FE. All right, when you say congruent, you should have the bar on top. Now let's do the second and third letters. All right. So second and third, we have BC matches ED. All right, so BC is going to match ED. And then finally, we can do the first and third, first and last letters to see which sides are congruent. All right. So we have AC matches FD. All right, so AC is congruent to FD. All right, so that's how you do the angles and the sides. Now here is the diagram, and you can see the sides that match have the same number of tick marks on each side, and the angles have the same number of marks as well. So we can see from the number of marks, angle A is going to be congruent to angle F. Angle B matches angle E. Angle C matches angle D. All right, the same thing is true for the sides. This side right here is AB, and we can see it is marked the same as this side right here, which is triangle side length FE. Okay, and we can see AC matches FD. We can see BC matches ED. So those are the sides and the angles. See, they have the same number of marks. Now, just so you know, there's no one way to write this congruence statement. Okay, you can mix these letters up as long as you match them up on the other side as well. So you see the red letter A, we can take that and put it last. But then on this one, we also have to take the red letter F and put that one last. Okay, and then you would have B, C, A, which is what they wrote here. And you would have E, D, F, which is this one right here. All right, so if you change one side, you have to change the other side the same way, as long as they match on both sides of the congruent symbol. All right, please pause and see if you can write the congruent statement for these two triangles. I'll give you a hint. You should have 3 letters and the congruent sign followed by 3 letters. Okay, and there's actually 3 different ways to do this. All right, let's start by matching up the angles. Okay, this one on the left here will be the triangle on the left. And this side here will be the triangle on the right. Okay, it's not a right triangle, I'm just saying it's on the right. All right, let's match it by the angles. We have K, because it has this 1 mark, matches S because it has this 1 mark. So K goes here and S goes here. And then match the ones with 2 marks. We have L, and the one with 2 marks matches R. So L matches R. And finally the one with 3, 1, 2, 3, that's J. And on the other one, 1, 2, 3, that's T. So KLJ is congruent to SRT. All right, now you can mix up the letters. If you want to take the J and put it first, you can make it JKL. Take the T and put it first, that'll be TSR. All right, you can take the L and put it first, that's LJK. Take the R and put it first, that's RTS. And actually, there's more combinations, but we'll just leave it at that. Okay, you can mix up the letters on both sides. And of course, if you want, you can put the triangle symbol in the front. Okay, I left that off because I didn't have room, but if you want to say it's a triangle, you can put the triangle symbol in front. Okay, so please pause for a moment and see if you can match up the sides that are congruent. All right, the ones with 1 mark, this one right here is JK, and on this triangle, 1 mark, ST. So JK is going to match ST. Those are both congruent. Now the ones with 2, right here you have KL, and right here you have RS. So KL is going to match RS. And then finally, the one with 3, right here, that's JL, and right here, that's RT. So JL is going to match RT. All right, with the 2 letters, the order doesn't matter. That's just a line segment. You can reverse the 2 letters. It won't change. All right, example 2 in the diagram, DEFG is congruent to SPQR. They want us to solve for X and then solve for Y. Let's take a look. All right, so DEFG is congruent to SPQR. They want us to solve for X. If you look at the side lengths or angles, this one here has both a Y and an X, so we can't solve for both of them at the same time. But this one here, that represents the length of QR. All right, so all we have to do is match that to the length on this one. So if you look at QR, that is the last 2 letters, the 3rd and the 4th. So QR is going to match FG. All right, so let me write that on the side. QR is congruent to FG. All right, so this is the way you write it when you're just matching the segments, okay? But if you want to make the lengths the same, we say QR without the bar equals FG. All right, remember when you say equals, you're referring to the length without the bar on top. So now that we know QR equals FG, we can just set them equal. We see QR is this right here, that's 2x minus 4. And that equals FG. Let's find FG. All right, FG is down here, and that's just 12. So that equals 12. Okay, see if you can solve for x, please. Okay, solving for x, I want to get all the numbers on the other side. I'm going to add 4. 4 minus 4 is gone. Bring down your 2x. 12 plus 4 is 16. And dividing both sides by 2, the 2's cancel, and x is 16 over 2, which is just 8. All right, now we want to solve for y. We have x equals 8, so I can put it in right there. All right, x is going to be 8. And here's the y right here. So this measurement is basically this angle right here. That's angle Q. All right, so we have angle Q, and we're going to find out what that is congruent to. All right, if you look at the statement, angle Q is the third letter, so pick the third letter right here, angle F. All right, so angle Q is congruent to angle F. And that means that the measure of angle Q equals the measure of angle F. Okay, remember when you use measure, you use equal, not congruent. But anyhow, angle Q is 6y plus x. And angle F, we can see on the other figure, that angle F is 68 degrees. So the measure of angle F is 68. Now we said a minute ago that x equals 8. So that's going to be 6y. And in place of x, that's going to be an 8. And that equals 68. Okay, solving for y. I subtract 8 on both sides. The 8's cancel. Bring down your 6y. 68 minus 8 is 60. And if you divide both sides by 6, the 6's cancel, and 60 over 6 is just 10. That equals y. All right, example 3. If you divide the wall into orange and blue sections, will the sections of the wall be the same size and shape? All right, well, we can definitely match all 4 sides. All right, we see that this side matches this side, that's 1. This side matches this side, that's 2. This side matches this side, that's 3. And this side right here is shared by both sides. So we can make that equal to itself. So that's all 4 sides. Let's see if we can do all 4 angles. All right, we have right angle matches right angle, and right angle matches right angle. Okay, so we just did 2 pairs of angles. And really, right here, we have same side is supplementary. So we know that the top is parallel to the bottom, and now we can just look for that Z shape, which would be alternate interior angles. All right, so if I go like this, and this, and this right here, the angles inside the Z are congruent. So this one here, angle 1, matches that one there, angle 4. Now let's see if I can do the Z for angles 2 and 3. And that would be the last angle. All right, so for 2 and 3, I'll do the Z shape like that, and like that, and like that. Okay, inside the Z, we have angle 2 and angle 3. Those are alternate interior angles. Okay, as long as the lines are parallel, then they are congruent. So all 4 pairs of angles match. That proves that the 2 halves are congruent. Okay, right here we have ABGH is congruent to CDEF. See if you can solve for X by matching on both sides, and then plug in for X and find the measure of angle H. All right, so if you look, here's angle H, and that's going to be 4X plus 5. All right, we want to match it up. So angle H, or letter H, is the last letter. The last letter right there is F. So angle H is congruent to angle F. All right, and that means the measure of angle H is going to equal the measure of angle F. All right, you can go right to this step if you want to. You don't necessarily have to write that first step. But let's match them up. The measure of angle H is 4X plus 5. And the measure of angle F is 105. All right. The opposite of plus 5 is minus 5 on both sides. 5 minus 5 is gone. Bring down your 4X. 105 minus 5 is 100. And dividing both sides by 4, 100 over 4 is 25. Now they asked us to find the actual measure of angle H. So of course we want to take that and plug it in. All right, X equals 25. If you go right here, you put the 25 in, you get 4 times 25 plus 5. Okay, that's 100 plus 5, which is 105, and that's in degrees. Does the answer make sense? Well, yeah, you can see right here, angle F is 105, so they match. So that's exactly what we wanted. Okay, please pause and see if you can prove triangle PTS is congruent to triangle RTQ. You can easily match up the sides, but see if you can match up the angles as well. All right, for the sides, that's pretty easy. We see the ones with 1 mark, that's PS, matches this one, that's QR. So PS equals QR. You can also write them as congruent as well, but I'm being lazy. All right, the ones with 2 marks, right here, that's PT. Ones with 2 marks, right here, that's TR. So PT matches TR. And finally, with 3 marks, that's ST. 3 marks, that's TQ. So ST matches TQ. Now let's do the angles. All right. Now here we have the X shape right here in the middle. All right, if you look at this X shape right here, this angle matches that angle. All right, so we need 3 letters right there. So this angle is going to be PTS. Angle PTS. And it's going to match this one here. That's going to be QTR. Angle QTR. All right, I don't know why I put a comma there. PTS is congruent to angle QTR. All right, and you can see that they made parallel lines on either side. See this little triangle here, this little triangle here. This is parallel to that. So just do the Z shape or N shape once again. If you go like this, and this, and that. This one here inside the Z, and inside the Z, those are alternate interior. So P matches R. All right, so let's do that. Angle P and angle R. All right, angle P is congruent to angle R. And the last one, we just do the exact opposite with the Z shape. All right, and grab the other angles. This time we're going to grab S and Q. So if I trace this down, and like so, we're making a Z or an N shape using the parallel sides. Inside the Z or inside the N, right here is angle S, right here is angle Q. So S matches Q. All right, angle S is going to be congruent to angle Q. So for the first angle, the verticals, I had to use 3 letters, because if you say T, we don't know if it's this one or this one. So I had to use 3 letters. All right. But on the other ones, I just used 1 letter. It's obvious this is P, this is R, this is Q, this is S. So 3 sides and 3 letters, 3 pairs of sides and 3 pairs of angles. Theorem 4.3, the third angles theorem. If 2 angles of one triangle are congruent to 2 angles of another, then the third angles are also congruent. Let's take a look. Okay, right here, you can see that angle A matches angle D. All right, so that's this right here. And then you can also see that angle B matches angle E. That's that right there. So since we have 2 pairs of angles that match, the remaining angles, angle C is going to match this angle here, remaining angle F. Okay, C matches F. So why is that true? Well, the reason it's true is because the interior angles of the triangle always add to 180. All right. So if you subtract this and this from 180, you'll get this one here. And if you subtract this and this from 180, you'll get the same measurement here as well. Okay, so that's why it works. So if you have 2 angles that match, you know that the third angles match. Example 4, find the measure of angle BDC. All right, if we go from BDC, that's going to be this whole thing right here. All right, so see if you can solve for that, and I'll give you a hint. If this is congruent to that, and that is congruent to that, you can fill in the missing angle measurements and then find the third one. So please try it. All right, see this one angle here? It has 1 mark. That's 45. This one here has 1 mark. That's also going to be 45. This one here has 2 marks. That's 30. This one here has 2 marks. That's also going to be 30. Okay, so I'll highlight the triangle in yellow in case you didn't see it yet. We are looking at this triangle right here. All right, and we're looking to find BDC, this whole thing. All right, so it's pretty easy at this point. We know that angles inside this triangle in yellow, they have to add to 180. All right, this one here is 30, and this one here is 45. So that's just going to be 180 minus 30 and 45. Okay, if you add these two, it's going to be a 75, and 180 minus 75 is going to be 105. All right, that's just 105 right there. So this is BDC. And that's going to equal 105 degrees. All right, please pause and see if you can find the measure of angle DCN. DCN is going to be this angle right here. All right, we have two angles, 75 and 68. We can find this angle in here. All right, remember the triangle angles add to 180, so we're going to subtract those two from 180. All right, that's going to be 180 minus 75 plus 68. And 75 plus 68, that's going to be 143. And 180 minus 143 is 37. So this one here is 37. And if you use vertical angles, this one here is also going to be 37. Okay? And now this one with one mark is 68. So this one with one mark is also going to be 68. Okay, and finally for the remaining angle, we just subtract these two from 180. Okay, I can't zoom in anymore, but that angle right there is going to be 180 minus 68 plus 37. Okay, 68 plus 37, that's going to be 105. And 180 minus 105 is going to be 75. So this angle right here is 75 degrees. All right, final answer. So to wrap it up, we use these two to find this third angle, and these are verticals right here. So the 37s match. See the X shape? That's why they're verticals. And then D matched S, so I just filled in the 68, and then I subtracted these two from 180 to get 75. All right, last two properties are simple, symmetric property. If ABC matches DEF, then DEF is congruent to ABC. So no big deal, you can just reverse the first and last part of the statement. And the transitive property, if ABC matches DEF and DEF matches JKL, that means ABC is also going to match JKL. So that's it.